Hi, I'm going to walk you through the last written homework that you turned in Wednesday. Also, I'm posting the grades and on Canvas, and even if you got 100%, that doesn't mean that you did the problems correctly. So look at the Canvas grade book. You'll see my comments. If you go to that assignment in the grade book, you'll be able to see the comments that I made about your particular homework. So if you did one of the problems correctly but got the other one wrong, I'll put that in the comments so that you can try it again. Okay, so here I'm going to go through both problems and show you what it is that I want to see you writing in the homework and also on the test if these problems show up on a test. So the first one was 4.1, number 56. And so in the homework, you would write this down. You would write, prove the identity, secant theta minus cosine of negative theta equals sine squared theta over cosine theta. So that's what you would write down on your homework. And then I really want you to do this problem. I want you to always start by writing one side of the equation down on the left, and then on the right, you start transforming that into the other side of the equation. So what you're doing is you're proving that this equation is true for all values of theta for which it's defined, right? So any value of theta that you can plug into the equation is legal, right? And this equation will always be true for any value that you can plug in. So the way to prove something is always true, the way to prove that an equation is always true is to start with one side of the equation and then show by simplifying it that you will eventually get the other side of the equation. So far in the course, we've just been starting with the left side and deriving the right side. We're going to be doing this for the rest of the semester. We're going to be doing much more complicated equations. And so generally what you do is you start with the more complicated side and derive the simpler side. But anyway, in this one, we're going to start with the left side. So on your homework and on the test, this is what I want to see you do. You write down one side, the left side in this case. Then you write the equality symbol and start transforming on the right side till you get sine squared theta over cosine theta. So the very first thing that we're going to do is we're going to use a reciprocal identity to rewrite the secant. So the secant of theta is really the cosine, or 1 over the cosine of theta. And then we're going to use the fact that the cosine function is even, and we know that, and I'm going to write it on up here, we know that the cosine of negative theta is always equal to the cosine of theta, right? Because it's an even function. So we can rewrite the cosine of negative theta in this equation as the cosine of theta. All right, so that's the first step. We wrote down the left side of the equation, an equality symbol, and then our first change to that, which was to use the reciprocal identity, secant of theta equals 1 over cosine, and then to use the evenness of the cosine function. All right, so now we're going to start transforming that, and we're going to keep everything on the right side. So the next thing I'm going to do is get a least common denominator so I can combine these two things. So I need a cosine theta in the denominator of the second term. So I'm going to multiply the bottom and the top by the cosine of theta. So now if I multiply across there, the two fractions, cosine theta over 1 times cosine theta over cosine theta, I'll have a cosine squared theta in the numerator and just a cosine theta in the denominator. So let's rewrite. The first fraction stays the same. The second fraction becomes cosine squared theta over cosine theta. So if you don't write this step, You're not writing a correct proof. You have to write each of these steps. All right, so now that we've got a least common denominator, we can subtract. And remember, the denominator stays the same, but you just subtract the numerators. So we have 1 minus cosine squared theta over cosine theta. Now we recognize that numerator using one of our Pythagorean identities, one of our versions of the Pythagorean identities. So the main Pythagorean identity is cosine squared theta plus sine squared theta equals 1, right? But if we subtract cosine squared theta from both sides of this identity, we get sine squared theta is equal to 1 minus cosine squared theta. So that's the version we're going to use. In our fraction, we have a 1 minus cosine squared theta in the numerator, and we can replace it with just a sine squared theta. So let's do that. I have sine squared theta over cosine theta. And that's exactly what we wanted. We wanted that to be on the right side. And so we've done what we set out to do. We've proven that the secant theta minus cosine of negative theta is actually equal to the sine squared theta over cosine theta. So all those lines, all those steps, 1, 2, 3, 4 lines are required in the proof. You have to show how to get from secant theta minus cosine negative theta, how to get from that all the way to sine squared theta over cosine theta. All right, so practice those, memorize, make sure you remember the identities that we've been learning. And now the new identities, which are the even and odd ones for cosine and sine. All right, so then the next homework problem that we had was 4.2, number 56, the sketching of the graph. Very few people got this one right. You may have gotten the graph right, but you did it in a very incorrect way, or a lot of people just didn't even get the graph right. So the problem, and this is what you would write on your homework, you would write this: graph y equals negative 3 sine 2x on, and then it has the inequality, which is the interval negative 2 pi less than or equal to x less than or equal to 2 pi. Another way to write that without the less than or equals symbols would be like this. It's the interval from negative 2 pi to positive 2 pi with square brackets. So that is not the period. That's not even one. That's not one cycle, but that's what the book is asking you to sketch the graph of. Just sketch the graph of the function on this interval. And so the very first step is to figure out what interval you'll have for just one cycle of the graph. And then if that's not enough, then you'll graph that, and then if that's not enough, you'll extend it to the entire interval negative 2 pi to 2 pi. Okay? So to figure out one cycle, we need to get the period. And we also need the amplitude. In order to sketch the graph, we need the amplitude. So always, always, always start by finding these things: the amplitude, the period, and the 5 key points for getting one cycle. And that will be your frame. And then you'll set up your coordinate axes, and you'll label them. That'll be your frame. So the 5 key points are going to be required on the test, just like on the practice test. You won't get full credit if you don't show 5 key points. All right. So the amplitude is always the absolute value of the number in front of the sine or the cosine. So in this case, the amplitude is the absolute value of negative 3. So it's positive 3. The amplitude is always a positive number. And then the period, you could use a formula, 2 pi over b, So in this case, it would be 2 pi over 2, which would be pi. However, I strongly advise you to use an inequality so that you can also get the cycle, one cycle. Not just getting the period, but getting one cycle. And I'll show you what I mean. So we know that the period of the sine function, regular old sine or cosine, is 2 pi. So you start with a cycle for regular old sine or cosine, which is from 0 to 2 pi. So you write this down. To get the period, you write down 0 less than or equal to the argument less than or equal to 2 pi. Because one cycle of the regular sine function goes from 0 to 2 pi. And so the argument in this case is 2x. So always start with this. You don't start with negative 2 pi to 2 pi because that's too big. That's way more than one cycle. So we start with 0 and we end with 2 pi. And in the middle, we put whatever the argument is. All right, so now we want to solve this for x. So we divide everything by 2. And we get x is between 0 and pi. And so this tells us our period, right? All we have to do is take the bigger number, pi, and subtract the smaller number, 0, and we get pi. So that's great. That gives us our period, which we could have gotten using a formula. But also it tells us that our cycle is going to go from 0 to pi. So when we set up our frame, we know where we're going to start and where we're going to stop. 0 and pi are going to be our starting and our ending points for one cycle. So x equals 0 to x equals pi. So let's set up our frame. So so first of all, the problem asks us to go from negative 2 pi to 2 pi. We're going to start by just going from 0 to pi, and then we'll extend. Also, we need our amplitude. Our amplitude was 3, so we know our lowest and highest points are going to be negative 3 and positive 3. So now, what are the 5 key points? Well, you always start with the beginning and the end of your cycle. So 0 and pi are the beginning and ending points of one cycle. And we got that from our work on the period, right? So then what you do is you divide this little interval into 2 subintervals. So pi over 2 is the midpoint. And then you break these 2 little subintervals into smaller subintervals by finding those midpoints. So then we have pi over 4. And the other one is 3 pi over 4. So those are the 5 key points. You start with the beginning and the end of one cycle. So in this case, it was 0 and pi. Then you start finding the midpoints. There's the very middle, which was pi over 2, and then the 2 little midpoints, pi over 4 and 3 pi over 4. So the idea is to have 4 equal subintervals. And that gives us 5 key points. So now we put those on our axes. So 0, pi over 2, pi over 4, 3 pi over 4. So we're going to graph one cycle using those 5 key points, and then we'll extend it. So with the sine function, we know it always starts at 0 and ends at the same place. But just to double check, let's plug it in. Let's plug in 0. So when we plug in 0 to the function, negative 3 sine of 2x, if x is 0, then 2x is also 0, right? 2 times 0 is 0. So sine of 0 is 0, and negative 3 times 0 is also 0. So we have a point there. And we know that the end of our cycle is going to have the same y coordinates. So we just plot that point there. So we know it's 0 at 0, so it has to be 0 at pi. So those 2 points are plotted. But we also know the sine function is 0 right halfway in between those 2 points. So I don't even need to plug it in. I know I could just put a point on the x-axis at pi over 2 because it goes up, comes back down, or it goes down and comes back up. Okay? So in this case, now I need to know what the y coordinates are for pi over 4 and 3 pi over 4. I know one of them is going to be the highest point and the other one is going to be the lowest point, right? One of them is going to be positive 3 and the other one's going to be negative 3. I don't want to guess, so I'll plug one in. So if I plug in pi over 4 into the function, 2 times pi over 4 is pi over 2. Sine of pi over 2, I know, is 1. You guys have to have those memorized by now. Sine of pi over 2 is positive 1. But then, multiplying that by negative 3, I get negative 3 times positive 1, which is negative 3. So for pi over 4, the point is down here, negative 3. And that means for 3 pi over 4, it's going to be up there, positive 3. And then I just connect those, and there's one cycle. And finally, a lot of people on the homework just graphed one cycle correctly, but they didn't extend it. So now we need to get this graph from negative 2 pi all the way up to positive 2 pi. So all we have to do is repeat this cycle 3 more times. So you can put a couple points on the x-axis, divide up. I don't need to write what all these points are. I just write, make sure I've got 4 tick marks, right? The tick marks tell me where to plot the points. And so putting tick marks with or without labels, it doesn't matter. So now, with all those tick marks, I know how to sketch the rest of the graph. So first I'm plotting some x-intercepts. I know it's going to go through the x-axis at these points. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi, because it's a periodic function with period pi. I can figure out where all those x-intercepts are, and then I can tell where it's going up and where it's going down. So I know I'm going to have those 2 points over there, a couple of high and low points over there. I don't have to plug anything in because I can see the pattern, right? And then I can connect all these dots. And there's the rest of the graph. So very little plugging in. Finding 5 key points to get one cycle. There's a little bit of plugging in that you need to do, but not much, because you know the patterns, right? You know what the sine graph looks like. And then once you get one cycle, you can extend it to whatever the desired interval is. In this case, the desired interval was negative 2 pi to positive 2 pi. All right, I'm going to make another video with some basics and some other suggestions. So please post any questions about this or about the exam on Canvas. Post them as replies to my announcement that I posted on Monday night. I posted an announcement called Reminders. Post your questions as replies to that. And I'll see you soon.